We purchased a few air quality meters because I'm interested in this stuff. So let's go see how it happens. All right. We start with ethanol. Ethanol is alcohol. This is denatured alcohol. And I pour a few ounces into a little bowl. Now I'll go through my meters here and we can see how things, okay, the bottom number here is PM 2.5. That meter is CO2. Then I have humidity and temperature in degrees C. Above I have temperature and humidity, TVOC, formaldehyde, and CO2 in parts per million. Over here, the same PM, CO2. Then up here I have volatile organic compounds, formaldehyde, and CO2 in ppm. All right. So this alcohol, which evaporates at room temperature at a fairly good rate and is an organic compound, should impact these meters. And we're seeing the meters on the top have extreme elevated VOCs, formaldehyde, and CO2. However, the lower meters do not have elevated CO2 levels. And I think it has to do with how these sensors read their data, read the environment. But I trust the meters on the bottom more. You can see that the top meters reading 5,000 parts per million, that is 5% CO2. And I would expect the lower meters to be reading somewhat higher than they are. But both of the top meters have elevated CO2 levels when there's really no reason for them to be elevated in this environment. I do believe that the volatile organic compound numbers are okay. So then we tried hot water, and I had taken some of these into the bathroom while I took a shower, and they had elevated readings. So I didn't know if boiling water would do anything. So I boiled some water in a microwave and set it there, and all the meters seemed to stay somewhat ambient. This is a good placebo test. You know, if I sprayed the water, it might do something different. But it didn't impact the CO2 on any of the meters. It really doesn't impact volatile organic compounds. It doesn't impact the formaldehyde readings. Even the humidity really didn't change much. All right, let's move on to the next one. Hairspray. This is Aquanet Hairspray. I use this often on my 3D printer platens, and so it's something I would typically spray on a hot platen. You can see the two bottom numbers on the left and the right go up. This is particles floating in the air. And it's counting them, and it's saying, hey, there's a lot of PM 2.5 in the air. Now, then we see the CO2 readings on the upper units go above 1%. The one on the left is 6%. If I was in a room with 6% CO2, I believe I could detect that. However, the bottom units are ambient. 400 and 500 ppm of CO2 is ambient levels. There's a vast difference between the upper readings and the lower readings. Next, we have Clorox. This is a common cleaner to clean countertops and bathrooms and kitchens. I'm not advertising for Clorox. It was just a bottle I had. I sprayed it just like I did the hairspray, but 2 squirts, and we'll see how things, see what they do. I take about a half hour between tests to clean out the air and get the meters down reading at an ambient level. This takes some time. However, you can look at all the numbers and see that they're not jumping around as soon as I spray the Clorox down. The numbers are just kind of floating around. Now, none of these meters have a fan, and the air in this area is rather still. So the gases that are evaporating off the plate there are not moving around much. Now you'll notice the left meter on the top will start going up, and as I place the Clorox container, the cleaning container, and I thought that it was because I had pointed the nozzle toward that device. So I set it down, and I saw the left one go up, and I thought it was because I had the nozzle pointed in that direction. However, so I moved it to the back a little bit. But the top and the bottom, the top 2 meters are the only one that are really, levels are getting raised. The bottom meters really don't have any reaction to this. In fact, it's only the left meter that is measuring high readings. You can see the little arrow at the bottom of the screen on the top meters in the yellow or brown, whereas the meter on the top one on the other side is still in the green area. Could be just the way the air is moving in this. Just difficult to explain. The meter on the left is far more sensitive. I don't believe the numbers are correct. This is a highly... All right, this is brake fluid. Now, brake fluid is not something we normally spray in the house. However, it's a good solvent, a good cleaner, and I wanted to use it as an example of what could make high VOC numbers. And you see the numbers on the left, upper left, going up, and then the numbers on the right, upper right, going up. Fully expected, a solvent being dispensed is going to have high amounts of volatile organic compounds. The 2 meters on the bottom really have no impact on this. I believe it's the way these upper meters are deriving their CO2 that causes them to read erroneously or quite a bit different than the lower meters. The lower meters are rather stable, but they do react to humans being around them. All right, now I wanted to show you a PM production, or when you release amounts of particulate matter into the air. So I'm going to light 3 candle wicks in this candle, and I want you to notice that the bottom numbers on the bottom scales are not going up. When it's flaming, there is no or not much reaction. I had them going for about 3 minutes. I edited that out. This is the PM production. When they get smoldering candle wicks or smoldering material, you'll see the PM numbers go up. So the one on the left goes up to 400 and now starts coming back down. PM values go up and down fairly quickly, and that has to do with how sticky and staticky the PM particles are. They like to find a home and stick to it. So as soon as they do, they're not floating in the air anymore. So it's counting the particles, PM 2.5, and when they get down to 50, that's considered background levels. And it turns green. So this is a nice test showing how different meters react to different stimulus, different materials being sprayed. And I want to emphasize that if you have a meter, it may not be believable, that some of the values that it's giving you may not be calibrated, they may not be reliable. In a nutshell, burning and smoke is going to raise your PM 2.5 levels. Alcohols, cleaners, solvents are going to raise your volatile organic compounds. Humans, pets, and carbureted beverages are going to raise your CO2 levels. Thank you for watching. Enjoy your meters. Smokeless Chimney. Warm homes and clean air for everyone. www.smokelesschimney.com